Today we are going to discuss the topic Enhanced Entity Relationship Diagram. Since 1980s, there has been an increase in emergence of new database applications with more demanding requirements. The basic concepts of ER modeling were found not sufficient to represent requirements of newer and more complex applications. So the response was to develop additional semantic modeling concepts. So the enhanced ER model includes all modeling concepts of basic ER, such as entities, attributes, and relationships. It also includes some additional concepts like subclasses and superclasses, specialization and generalization, categories, and attribute inheritance. So the resulting model is called the Enhanced ER or Extended ER model, and it is used to model applications more completely and accurately if needed, which was not possible using basic ER. It includes some object-oriented concepts also, such as inheritance. Subclasses and superclasses. An entity type may have additional meaningful subgroupings of its entities. For example, an employee may be further grouped into secretary, engineer, manager, technician, salaried employee, hourly employee, etc. This feature was not there in basic ER, and each of these groupings is a subset of employee entity. Each is called a subclass of employee, and employee is a superclass for each of these subclasses. These are called superclass-subclass relationships. For example, employee is a superclass of which secretary is a subclass, employee is a superclass of which technician is a subclass, etc. Here we can see an example. We can see that there is an entity type person. Person is having attributes name, street, and city. Person can be further divided into subclasses employee and customer. Here employee is having a specific attribute salary, and customer is also having a specific attribute credit rating. Employee can further be subdivided into subclasses officer, teller, and secretary based on the nature of the job. Officer is having specific attributes, teller is having specific attribute, and secretary is also having specific attribute. And here this means that officer is an employee, teller is an employee, and secretary is also an employee. Here employee is a person and also customer is a person. This kind of a representation was not possible with basic ER, and here this enhanced ER diagram can represent the system more accurately. Subclasses and superclasses are also known as E-say relationships. Secretary is an employee, technician is an employee, etc. An entity that is member of a subclass represents the same real-world entity as some member of the superclass. The subclass member is the same entity in a distinct specific role. The subclass member employee is the same entity person but in a distinct role, that of an employee. An entity cannot exist in the database merely by being a member of a subclass. It must also be a member of the superclass. A member of the superclass can be optionally included as a member of any number of its subclasses. For example, a salaried employee who is also an engineer belongs to the two subclasses, engineer and salaried employee. It is not necessary that every entity in a superclass be a member of some subclass. Next is the attribute inheritance in superclass-subclass relationships. An entity that is a member of a subclass inherits all attributes of the entity as a member of the superclass. Also, it can inherit all the relationships of the superclass. Next is a very important concept, specialization. Specialization is the process of defining a set of subclasses of a superclass. The set of subclasses is based upon some distinguishing characteristics of the entities in the superclass. For example, secretary, engineer, technician is a specialization of employee based upon job type. a superclass can have many specializations. For example, in addition to the above mentioned subclass, another specialization of employee based in method of pay is salaried employee, hourly employee. Superclass, subclass relationships and specialization can be diagrammatically represented in ER diagrams. Attributes of a subclass are called specific attributes. For example, typing speed of secretary. The subclass can participate in specific relationship types. For example, belongs to of hourly employee. This is an example of a specialization. We are having an entity employee having attributes name, SSN, birth date, address and job type. Here SSN is the primary key attribute. Employee is divided into 3 subclasses based on job type, that is secretary, technician and engineer. Secretary can inherit all the attributes of employee. In addition, it is also having a specific attribute, typing speed. Technician can inherit all the attributes of employee. In addition, it is having a specific attribute, T grade. Similarly, engineer can also inherit all the attributes of employee in addition to its specific attribute, engineer type. Here, this D means that this is a disjoint set. No specific entity in secretary can be a member of technician. This is the same with all the 3 subclasses. Next is generalization. Generalization is the reverse of the specialization process. Several classes with common features are generalized into a superclass. Original classes become its subclasses. For example, car and truck can be generalized into vehicle. Both car and truck become subclasses of the superclass vehicle. Here we can view car and truck as a specialization of vehicle, or alternatively we can view vehicle as a generalization of car and truck. This is a bottom-up design process, that is, it will combine a number of entity sets that share the same features into a higher level entity set. Specialization and generalization are symbol inversions of each other. They are represented in an ER diagram in the same way. And the terms specialization and generalization are used interchangeably. Constraints on specialization and generalization. 2 conditions apply to a specialization or generalization. One is the disjoint constraint and another one is the completeness constraint. Disjointness constraint specifies that the subclasses of the specialization must be disjointed. That means an entity can be a member of at most one of the subclasses of the specialization. This is specified by D in ER diagram. If not disjointed, it can be overlap. That is, the same entity may be a member of more than one subclass of the specialization. This is specified by O in the ER diagram. Next is the completeness constraint. We have 2 types, total and partial. Total specifies that every entity in the superclass must be a member of some subclass in the specialization, generalization. This is shown in ER diagrams by a double line. Partial allows an entity not to belong to any of the subclasses. This is shown in ER diagrams by a single line. Hence, we have 4 types of specialization or generalization: disjoint total, disjoint partial, overlapping total and overlapping partial. Generalization is usually total because the superclass is derived from the subclasses. This is an example of disjoint partial specialization. Disjoint because the employee is divided into secretary, technician and engineer based on job type, and no secretary can be a technician, no technician can be an engineer, and no secretary can be an engineer. So these 3 subclasses are disjoint. Now why is this partial? It is because there can be an employee who does not belong to secretary, technician or engineer. So this is all about ER diagrams. Thank you.